Okay, so here's the deal. This is what I want you guys to do. I want you guys to graph this function, and I want you to put it on 4 different graphs. Okay, this is function f. We're going to graph him. He's the basic one. It's just 3 to the x power. Okay, and then we're going to graph 3 to the x plus 1. That's the g function. And we're going to graph 3 to the x minus 2. That's the h function. And we're going to graph negative 3 to the x power. That's the k function. And then finally the j function right there. And the purpose of this is to compare all of these functions to the mother function. You can call this the mother function. You call it the parent function, whatever. All of these are transformations of this dude. And so we're going to make tables for all of them so you guys can see what those transformations do. And notice I whited out most of the stuff. Because blank equals f of x plus 1, the graph of g can be obtained by, well, what does that mean? F? Well, f is over here. Because g is just f when you plug in x plus 1, that's what this looks like after you plug in x plus 1. How can you obtain the graph of g? Okay, that's the question I want you guys to be able to answer. Same with this one. Because h is just like subtracting 2 from the f function, that they're the same. How can you graph that one? How can you obtain that one? Okay. So if I was graphing f, the first thing I'd do is I'd make a table. I put f of x for my y value, and then I'd have the x column. So for the x column, you can pick whatever numbers, but I'm going to pick negative 2, negative 1, 0, 1, 2, and 3 because those numbers will come out nice and pretty when you guys plug them in. If you guys plug in negative, or let's start with positive 3 into 3 to the x power, what would you get? 3 times 3 times 3, what would that be?
9.
No? 27. 3 plus 3 plus 3 is 9, but this is 27. And then if I raise 3 to the second power, what would you get? 9. And then you get 3 if you raise it to the 1 power. What if you raise it to the 0 power? You get 1. And then what if I raise it to the negative 1 power? Ooh. Yeah, that's 1/3. Okay, or if you plug that in your calculator, you would get 0.3333. Repeating. And then what about to the negative 2? Tell your neighbors. Go. All right, so your neighbors should have said 1 over 9. Or what is 1 over 9 as decimal? I don't know.
It would be
0.00 something?
Yeah, 0.1 repeating.
0.1 repeating? Oh, there you go. Okay. Then you graph. Okay, I'm going to have I'm going to space out my x's pretty good. Negative 2, 3, and I'll put a 1 right there. Now, what about for my vertical axis? What would you guys count by on the vertical axis? My highest number is 27. What would you guys count by? 3s? Oh, that's not a bad idea. I didn't count by 3s. I count by 5s. All right, so we have 5, 15, and 25. Okay, and then when I graphed it, I graphed negative 2 first, and then negative 1, and then 0. 0 only goes up to 1. It's fairly low. And then 1 should go up to 3. And then 2 goes up to 9. Finally, we're making some headway there. And then 3 goes up to 27. And then to finish graphing the function, we must connect all the dots. All right? There you have it. Now, how would we put the g function onto this? What would you start with to graph that? Same thing? Yeah, why not? Okay, so we put it on there. This is my g function now. I'm going to use negative 2, negative 1, 0, 1, and 2, 1, 2, and 3 again. Here, you guys fill the table. So let's make our table for this one. If I plug in negative 2, I get 1/3. If I plug in 1, I get 1. If I plug in 0, I get 3. If I plug in 1, I get 9. And then if I plug in 2, I get 27. If I plug in 3, what do I get? 81. Okay, so when I graph these points on my graph, this is where I would graph them. What does it look like that did? What does that plus 1 do to the f graph? Shifts the f graph to the left. And that's pretty obvious when you actually do the table. Because look at this. The negative 2 got a 1/3. But what did 1/3 have before for an x? Had a 1. And so the negative 1, or it had a negative 1. The negative 1 changed to a negative 2. Look at the 3. The 3 has a 0 for the x. over here, what did the 3 have for the x? 1. So now the x is 0. So going from 1 to 0 is shifted to the left. So whenever you see a +1 on the x, it shifts the graph to the left. Now, what does -2 do right here? And what does the -3 in front do? And what does the negative on the x do to our graph? You guys all done with your tables?
Not all of them.
Okay.
I did 1 table.
3 more minutes? Now, to make the table for the h, it says we're subtracting 2 from 3 to the x power. You can actually kind of cheat on this and just take all these y values right here and subtract 2 from all of those. So this would be 25. This would be 7. And then we have a 1. And then we have a -2. And then when we subtract 2 from 1/3, that would be a -1 2/3. And then we subtract 2 from 1/9, that would be a -1 8/9. And that's what you would have. So what would the h function appear to do on our graph? Now, I'm not going to graph it. You guys probably already did. What does it look like the graph did from the f function? It shifted what? It shifted down 2. So instead of a -2, and if there was a +2, what would you expect the graph to do? Shift up 2. Ah. Sorry, that's supposed to be a -1. Your face makes mistakes. I think he's talking to you. Let's look over. Let's look over at k. Now, k has a negative in front of the 3 to the x power. Now, the tricky part about this one, I don't know if you guys messed this one up, but that exponent does not see the negative. The exponent only sees the 3. So if you see something like this, that exponent only sees a 3. But if you see parentheses around the negative, then the exponent also sees the negative. So that means the negative is applied after we do the 3 to the x power, which means we have the same answers here, except all of them are negative. So we have a -1/9, a -1/3. That would be a -1, a -3, a -9, and a -27. So if I were to look at the k graph, how would that compare to the f graph? It reflects about what? The x-axis. And so it would actually look like this and shoot downwards. Yeah, right? Okay. What about our j function? What changes on our j function? Actually did the table, you would get 9 right here, 3, you would get a 1, and then you would get a 1/2, and then a 1/3, a 1/9, and then a 1/27. Now this graph right here starts high on the negative side. It would look like this. Now that's a reflection about the y-axis. So these two are reflections, the k and the j, and the g and the h, those are shifts. And these are how you transform exponential functions.